When we were children, they always told us the same thing. There is no sound in space. We've heard this so many times that we don't even question it anymore. It's written in textbooks, repeated in documentaries, and shown in movies. A spaceship explodes, and those inside are torn apart. No screams are heard, because there is no air in space to carry sound waves. That's true. But because sound, what comes to mind when we speak, what our ears tell us, is only a small part of the story. The universe speaks across a much broader range of frequencies, and we only began to realize this in the 1930s. It's only very recently that we've truly begun to listen. Think about this. The first radio broadcast on Earth took place in 1895. From that moment on, electromagnetic waves have continued to travel through space at the speed of light. Today, those first signals are about 130 light years away. In the grand scheme of the universe, that's not even a drop in the bucket. What if the universe was sending signals long before we had radio? What if an ear that knew how to listen had heard them?
In 1931, Karl Jansky, a young engineer, was investigating interference in transatlantic radio communications. His task at Bell Laboratories was simple: find the source of the interference and eliminate it. He worked for months. Some of the interference was expected from storms. Some came from nearby lightning. But there was one signal that the equipment just couldn't pinpoint. It was always there, for hours, days, weeks. And then he realized. This signal repeated every 23 hours and 56 minutes. But it wasn't a solar day. It was a sidereal day, the Earth's actual rotation period. The signal didn't come from the sun. It had to be coming from the center of the Milky Way. Jansky had heard the universe's pulse for the first time in human history, but he couldn't quite figure out what it was transmitting. He published his paper, was largely ignored by the world, and passed away without conducting any further detailed research on the subject. But it had left its mark on us. Have you ever wondered, what was the man who first detected that signal feeling? The moment he noticed that high-pitched, constant hum coming through his headphones.
In 1955, two astronomers, Bernard Burke and Kenneth Franklin, were looking for something entirely different. Their target was the Crab Nebula, but their radio telescopes kept picking up strong, diffuse signals from another source. At first, they thought it was a malfunction. Then, when they pinpointed the source, they were stunned. Jupiter, the largest planet in the solar system, was emitting powerful radio bursts at regular intervals. The source within it was Jupiter's massive magnetic field, about 20,000 times stronger than Earth's. This field accelerated charged particles within the planet, causing them to generate radio waves. NASA gradually converted these into audio frequencies. What you hear is like an ocean, sometimes like a storm, and sometimes like something you've never heard of or can't describe. But when you listen to it, it stirs something strange inside you. It's as if something is trying to communicate with you, but you don't understand its language. This sound from Jupiter is available to everyone in NASA's archives. If you want, you can go listen to it right now.
Jupiter isn't alone. The sun speaks too. There are constant eruptions and oscillations on the sun. These oscillations, much like a modern musical instrument, resonate from one end of the sun to the other. Scientists study these waves through solar seismology, or helioseismology, just as we understand the Earth's interior through earthquake waves. And when these oscillations are converted into sound, they produce a very low-frequency, deep, almost hissing hum. The sun is like an instrument that vibrates every second. But it's not alone. Its stellar vibrations vary. Some are regular, some are chaotic. Some are very young and fast. Others are old and slow. From the way stars vibrate, we can determine their age, size, and even their internal energy. This is called stellar seismology, astroseismology. Think about it for a moment. We can understand a star without even seeing it, simply by listening to its voice. It's as if, in a dark room, we could learn everything about someone just by the sound of their breathing.
In September 2015, in the early hours of the morning, two massive detectors vibrated simultaneously. LIGO, Laser Interferometer Gravitational Wave Observatory. Two facilities located 3,000 kilometers apart in the states of Louisiana and Washington. Each consists of L-shaped tunnels stretching 4 kilometers. Laser beams travel back and forth inside them, and if space-time can be bent, the length of these tunnels changes, even by subatomic distances. That morning, it changed. 1.3 billion years of light years away, two black holes had become bound together. They were slowly approaching each other, then merged at the last moment. And this merger sent ripples through space-time, like a stone thrown into a pond. Those waves traveled for 1.3 billion years, and when they reached Earth, they shifted LIGO's detectors by 1,000th the diameter of a proton. When converted into sound, this signal produces a short, sharp, descending chirp, a tiny fraction of a second, but it contains 1.3 billion years of information. The sound of two black holes' final dance. When scientists announced the detection, the audience erupted. Some were moved to tears, because Einstein had predicted the existence of these waves exactly 100 years ago. But even he never imagined we'd one day be able to hear them.
Let me go back even further, much further back. The universe began 13.8 billion years ago, not with a big bang, but instead by expanding all at once in that very first moment. And at its center was a dense, hot, opaque plasma. Not even light could pass through it. But sound waves were propagating within this plasma. Real sound waves, pressure waves, oscillations. When the universe was about 380,000 years old, it cooled and became transparent. At that moment, those sound waves froze in place, leaving a trace in the form of a mind-boggling pattern. Today, as we study the structure of the universe, we want to understand why galaxies cluster the way they do, and why they are concentrated in such intricate patterns. The answer lies there, in the sound waves from 13.8 billion years ago. The structure of the universe bears the fossil of that first sound. This is called baryonic acoustic oscillations, and today, cosmologists are examining the emergence of these patterns and attempting to engineer a solution by deciphering that first sound. So essentially, what we're saying is this. The shape of today's universe is a reflection of a sound that emerged 13.8 billion years ago.
What does all this tell us? To hear something, you first have to believe it exists. Then you need a reason to look for it. And finally, you have to build the tools to listen to it. We've been looking up at the sky for centuries, but only with our eyes. We saw light, bright spots, planets, clouds. Then we realized that the universe doesn't just emit light. It emits radio waves, X-rays, gamma rays, infrared, ultraviolet, gravitational waves. As we discovered its new language, we saw a different, universal face of the universe. Radio telescopes revealed quasars to us. X-ray telescopes showed us black holes. Gravitational wave detectors announced merging neutron stars. And we were shocked at every turn, because we thought we had it all, but the universe always opened yet another door. Right now, how many ears do you not have at your disposal? Today, how many signals are slipping past you? Signals that the human eye or ear cannot directly perceive.
Karl Jansky passed away in 1950 at the age of 44. The three leaders of the LIGO team, Rainer Weiss, Barry Barish, and Kip Thorne, who were the first to detect gravitational waves, received the Nobel Prize in 2017. There's a year in between. But both were doing the same thing. Listening. The universe hasn't left anything behind. We're just beginning to understand new connections. And its new path makes us feel even smaller, yet just as connected. Because within such a vast, ancient, and complex collection, on a small planet, in a short lifetime, it managed to capture that blossoming. So, what do you think the universe is telling us?
And more importantly, haven't we heard it yet? Let's discuss in the comments.